AB Calculus, Notecard 4, Limits and Asymptotes. This is Notecard 4 in the Notecard series developed by Stacy McMullen, formerly of the Dallas Independent School District. I was trained by Stacy in 2 summer sessions and also worked with a mentor that worked in association with Stacy, Tracy Etheridge. So we have a horizontal line, y equals b, is a horizontal asymptote, HA, if one or both the following limits exist. The limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x equals b. So you have 2 different horizontal asymptotes with the same function. Next says find HA analytically, next note card. And so note card 5 will show the analysis of this just using the functions, the equations. And a vertical line, x equals L, is a vertical asymptote, VA, if the limit as x approaches L from the plus or from the right side of f of x equals plus or minus infinity, and or the limit as x approaches L from the left side of f of x equals plus or minus infinity. And it says, let's find VA analytically, factor the rational function to find any removable discontinuities, a function with a hole, but can be redefined to fill in the hole. 2, cancel common factors if any, then set the remaining denominator equal to 0, and the vertical asymptote is x equals that number when you solve for setting the denominator equal to 0. So let's go look at some problems here, and really it says for 1, these are examples given for this note card. For 1 through 4 below, graph and or use the table on your calculator to find, and A, B, C, and D. Okay, and really we're going to use some analysis here, but mostly just looking at the calculator to find our asymptotes. So what I did is I previously graphed all these in the calculator, and this is number 1. We have 2x cubed minus 9x squared plus 4x over 3x cubed plus 6x squared plus 24x. It says, it looks like we have a vertical asymptote here. It says use the table view. Well, we can use the table view. Control T, this is a TI Nspire CX calculator. And if we go to the right, what we have is we are at negative 0.64, and we're getting higher and higher as we go. And what we're going to do here is, it's not readily apparent to you perhaps, but what we're approaching is negative 2/3. And part of it is, of how I know that is because of my understanding of the analysis behind it in conjunction with what I see in the graph. Also, if we go to I'm going to try this again. I'm going to go Control I, add graph, and just go get another one here. Okay, also we see at x equals negative 2, it looks like we have a vertical asymptote. To verify that that's the case, I'm going to go to Control T again, and this time go to negative 2. Well, 0 we are undefined. We don't see an asymptote. That's because we have a hole or removable discontinuity at x equals 0. And also, our vertical asymptote is where x equals negative 2. And then if we go to the left, we're going to come down close to negative 2/3. just like we did when we went to the positive. This time we're coming from below instead of from above. But our horizontal asymptote is going to be the equation y equals negative 2/3. And then for our vertical asymptote, that's going to be an x equals equation. It's going to be x equals negative 2. Okay, so that's going to be number 1. Next, we're going to look at problem 2. And as I did with problem 1, I previously entered this function, and I press enter here, and this is what we look like. We kind of see we have I don't see a vertical asymptote at all, because I don't see anything approaching negative infinity or positive infinity, and so I don't see anyway the definition of a vertical asymptote in this graph. Let's go ahead and look at the table view. T, and we see that we are undefined at 0 and 1. Okay, and then we're coming down to, looks like we're approaching maybe 0.5. Does that look right? Yeah, going to the right and going to the left. My guess is, from looking at the graph, I think we're going to see like maybe negative 0.5. Let's go see what that is. Okay, looks like we're approaching, yeah, negative 0.5. So our horizontal asymptotes we have y equals 1/2, and also I'll put a comma here, y equals negative 1/2. And we get to analytically, we can see why or how that's the case. We're going to leave it at that for now. And as far as vertical asymptotes, we see none. Okay, next, 3. We have fx equals 5 minus 9x over 8x cubed plus 1. So let's go look at this. I think we're going to be able to do some analysis according to the note card here. But Control I, add graph, and here is the function 5 minus 9x over 8x cubed plus 1. And this is what we're looking like here. Now it looks like our horizontal asymptote is a 0. And analytically I can understand why that's the case, but let's go look at the table view as was recommended. So Control T, and if we go to the right, we can see we're getting close to 0 in a hurry. And as we go to the left of the y-axis, we're getting close to 0 in a hurry also. And very close to 0. So that's that. So we would say for our horizontal asymptote, which is just 1, we're going to have y is equal to 0. Now, if our vertical asymptote, looking back at our note card here, says set the remaining denominator equal to 0, and the vertical asymptote is x equals that number. So we're going to do that with number 3. So I'm going to do is I'm going to say 8x cubed plus 1 is equal to 0. And if we just solve for x, subtract 1, so we have 8x cubed is equal to negative 1. And dividing by 8, okay, we have, I'm going to go to the right here, x cubed equals negative 1/8. And then solving for this, we can solve for x by taking the cube root of both sides. And so we're going to have, and that's negative 1/8. What we're going to have is the cube root and cube cancel each other, so x is going to be equal to the cube root of negative 1/8, which is going to be negative 1/2. So our vertical asymptote is going to be the equation x equals negative 1/2. And what I'm going to do for this is go back to our calculator and see how this x equals negative 1/2 looks like. That probably is the case here. So I hope you can see that. If we change the, we would, if we change the value, we could see like how far apart x's were in this table view, which we could do. I'm not going to do it this time. Last one, f of x equals ln x plus 2 over 6 to the power of x. And let's go ahead and look at our equation here. Control I, add graph, and here's that equation entered, function entered. And it looks like going to the right we have x equals 0, and Control T just to see what that does in our table view. See, we're getting really small there. This is a, see, this is, see, it says e to the times 10 to the 2.06 times 10 to the negative 9th power. So really, really small numbers. So we're going to say for our horizontal asymptote, we'll have y equals 0. In our note card, we'd be able to figure that out more quickly. And then for a vertical asymptote, x equals, now, when you look back here, it says vertical line, x equals L is vertical asymptote VA if as x approaches L from the plus side, which is what we have here, because when we're approaching 0 from the plus side, we're going down toward negative infinity, and it's only from the plus side. It does not, there's no limit, there's no left side limit, just a right side limit here, because we don't have a number less than, in fact, 0 itself, I believe, is undefined, or anything less than 0. So what we have here as a vertical asymptote is going to be x equals 0. So horizontal asymptote, y equals 0, vertical asymptote, x equals 0. So good luck in this. And number 5, note card 5, we're going to look at the analytics behind the horizontal asymptote. Good luck, and thanks for viewing.